Hey, hello all of you. Good afternoon. क्या दिवाली वाला माहौल लग रहा है आप क्लास में? Yeah. Hi Dhruv. We started just now. Venkitesh. Good afternoon. Good afternoon. Yeah, I was just telling that कि I think quite a few of your friends offline have gone home. Okay, for Diwali break maybe. Okay, so ठीक है. We will follow along. Yeah, Uber, I'm better now. I said that. But for the sore throat, I'm fine. I'm fine. Yes, Anugya, you have your Diwali break. Okay, Diwali कब है? Monday या Tuesday? शुरू हो गए. दिवाली तो हमारी everyday है. But when does officially Monday Tuesday कब है? Monday. Okay, fine. And वो एक और नया है spin, छोटी दिवाली, बड़ी दिवाली. Okay, something I learned coming to Delhi. Okay, फिर छोटी का भी छोटी दिवाली एक है. Right? You'll have a break on Monday, don't worry. Okay, so you have your Sunday off and your Monday off also. So आगे पीछे हो जाएगा आपका. Unless you want a day break on Dhanteras also, right? आपका बेटा धन सारा नॉलेज ही है. चलो, we start off now. आज ओके मैं समझा नहीं. हाँ हाँ. अच्छा, टॉकिंग अबाउट द रिकॉर्डिंग वाज नॉट अपलोडेड कट होने के बाद में. ओके, लेट मी चेक. ओके, व्हाट कुड हैव बीन द इशू. ठीक है ठीक है. अदरवाइज क्लास तो किया आप लोगों ने, राइट? या मिस किया अपने क्लास? मिस किया. अच्छा ठीक है. वैसे मेरा बस चले तो मैं बिल्कुल रिकॉर्डिंग ना दूं आपको. ठीक है, इससे बहुत नुकसान हो रहा है हम लोगों का. बट ठीक है, विल डू व्हाट वी कैन. चलो. So now I think this part is clear. What I mean by the chemical composition and the chemical differentiation of the interiors, which is in terms of what are the rocks, in terms of what are the minerals. We have crust, we have mantle, and we have the core. The crust is ocean and continent. The mantle is upper, middle, and the inner mantle or the deep mantle. Core is the outer core and the inner core. I believe no problems in this. Okay? You must know the approximate values of the densities. Have a sense of what minerals, what rocks, what is the basicity, acidity. Crust में oceans are thinner, generally 1 or 2 kilometers. They can be 3, okay, but continents are much thicker, 30, 60 kilometers. In some places almost 80 kilometers also. The continents are thick, oceans are thinner. This is fine. Now the mantle. This is the biggest part of the Earth's interiors. It has olivine minerals and its variants. The mantle has 3 parts: the upper, the middle, and the inner mantle, and approximate depths. Upper mantle till about 300, 350, 400. वो range रखना. The middle mantle up to 700, 900 kilometers, beyond which we have the inner mantle. And as we go inside the mantle, the rocks become more and more dense. The minerals become more and more mafic. Okay. The mantle, the core. One discussion we had how the temperatures, despite being very high, the inner core has not been melting. because we talked about the very high pressures, the extremely high pressure. In the outer core, pressure is relatively lesser, temperatures higher, and there are impurities that reduce the melting point of the outer core. Okay, so inner core जो है, this is inner core is iron, and it is nickel rich. The temperatures exceed 5000 centigrade, yet it is solid because of the intense pressure. एक term use किया था मैंने, pressure freezing. Okay, pressure freezing when the molecules can't escape, they remain together tight. In the outer core, temperatures 3000, 4000 है, इससे कम ही है. But there are impurities. There are silicate impurities. Plus, I said the pressure is also relatively lesser. The pressure at the outer core is almost half of the pressure at the inner core. And because of impurities, the melting point becomes less. Melting point is less का मतलब क्या है? That metal or that substance can melt at a lower temperature. So this is molten. Molten, very hot. A condition called as plasma condition. The electrons can start moving. They create electricity. There's a moving electric field around an iron-rich core, and that creates the process of, or the property of Earth's magnetism. Okay. So I think you have no issues on this front. Any doubts on this? Any queries on this, online, offline? Yeah, I mean, I remember these topics back then when I was studying, 90s की बात हो रही है, we had no clue about this, and हर sentence में हम surprise हो जाते थे. But now, given the classes, YouTube, content you have, so many of you enter the class with fair amount of idea already. So I don't think anybody is blank here, but ठीक है, class puts it as a part of an organized content. So most of you are comfortable there. Anugya, I'll enter that way. Then we talked about there is another scheme called as the mechanical differentiation or the mechanical layering. Mechanical, this is based on rigidity, based on relative hardness. How hard, okay, a layer is, okay. So we have crust, upper mantle, okay. We have middle mantle and inner mantle. In this scheme, the crust along with a part of the upper mantle, ये पूरा part. The crust is here and upper mantle का upper part, this part here. This to a thickness of approximately 100 kilometers tak. We call this as lithosphere. So these are two different layers in terms of the composition. They have different properties, but in terms of how they behave, they act as one unit. Think of a typical army maybe, right? They are all individuals, okay, but when they come together, they act as one unit. So despite the variations, there's something here where the crust and this part of the upper mantle, ये वाला part जो है, they act as one single layer. You cannot differentiate them much. And the remaining part of upper mantle, this is what is called as the asthenosphere. Asthenosphere, end of mantle, I said 300, 350 बोल लो, 400 बोलना है बोल लो. In that range, again it varies. Asthenosphere is, it has a unique property because of olivine concentration. Olivine has a property where if you apply pressure, if you apply stress, olivine will get deformed. Some books write the word plastic, okay, but we will not use that word. Plastic का कुछ और meaning होता है. There are elastic bodies and there are plastic bodies. So some books do write that it is like a plastic, but let's not say that. Simply call it as semi-molten. Semi-molten, remember it is a preferred phrase because there is no other phrase which can explain this. We have no other matter on the earth that behaves like this. ये बहुत अलग है. Okay. So we just call it as a semi-molten. But remember, this is actually a solid. It is not molten. Yes. हाँ तो ये सब terms हैं. Don't get trapped, please. I'm careful because technical terms हैं. So I don't want to take liberty from my side. Okay. So I'm going by what the standard books tell us. कोई article, कोई research होगा. I'm sure there are a lot of variants there. You keep the word semi-molten. Approximately, maybe you missed out half an hour of the class. If you can join in the end, so maybe 2 odd pages. Yeah. So semi-molten is the word, and this is a very interesting arrangement. The lithosphere on the top and something semi-molten below. The lithosphere is broken into pieces. They have called those as plates, and the plates are moving. The plates are floating again because of lack of any other word. The word floating is used for water, for liquid. This is not a liquid, but again I said, we don't have any other better phrase for this. So we use the word, the lithospheric plates are floating on the atmosphere. Okay. So this and the rest of the mantle is called as the mesosphere. The rest of the core is called as the barysphere. Okay. So ये हमारे discussion में ज़्यादा important है नहीं. Some books call this as the pyrosphere. Pyro as in hot, as in fire. Pyro means fire. So just mention and move on. I am concerned about this particular arrangement. The crust over the asthenosphere. Is it okay, all of you? The lithosphere over the asthenosphere. All good, all of you? Any doubts on this? Okay. Then we had one conversation on how the mantle, is solid, but parts of mantle are also molten. And those molten rocks, they can move. They move in what looks like passages. They move in what looks like, mantle pipes, you can say. And those movements are of different types. One movement is the molten rocks rise up, they move apart, they come down, and they circulate. This circulation is typically called as convection. Convection कहीं पर भी होगा, ऐसा ही होने वाला है. But something warm becomes light, less dense, will rise. It'll hit some surface it can't escape. It'll turn off. Become cooler, become denser, start sinking, and come back. So your mantle also has such circulations. We call those as mantle convection cells. And this idea was given by this man called Arthur Holmes. Arthur Holmes talked about the mantle is capable of such kind of circulations. And another way the mantle moves is, one is, I said, it can be convection. Second is, it rises and goes straight up and comes out on the surface. It rises up, it punctures the crust, it breaks the lithosphere, it comes out. There is no convection cell. So ये दो possibilities है. One is hot magma circulates like this, hot magma circulates like this, or hot magma can rise up like a rising tower, puncture this, comes out as volcanic eruptions. यहाँ पर भी होगा, it will rise up and puncture and come out here also, but what comes out here is much less than what moves like this. Right? So this is called as the mantle plumes. And these are convection cells. I'll discuss mantle plumes a bit more when I discuss volcanism and something around tectonics. अभी बस इतना ही जान के हम आगे move करेंगे. So I had one diagram to show you. One of you was asking me about that. So yeah, something like this. Can you all see it here? Okay, yeah. It's on the net. Nothing big deal here. So gas stove, a beaker of a container of water, and you are heating it. It becomes hot. It rises, circulates, comes back. So ऐसे ही कुछ हो रहा है for the mantle also. Okay, this part is hotter. Magma is rising. Okay, magma is rising, it's circulating here. These are the mantle convection cells, right? And we had one more diagram on this. Let me see if I have got it here. Yeah, this one. Okay, a bit more detail mein hai. Okay, so rising up, something comes out here on the ocean, some volcanoes here, and there is a astronosphere, convection through the mantle, it circulates. What it can do here, I'll come back afterwards. Okay, again, some of you have read tectonics. Okay, we'll maintain the flow of the sequence of events. All fine, all of you? What is mantle? How does the mantle circulate? What is its nature in terms of rocks, in terms of its state, in terms of its temperature patterns, and the two type of circulations, convection cells and mantle plumes. Okay, so we move on now back to our discussions. The next topic we took up was evidences of the interiors. How do we know about what is in the interiors of Earth, given that the Earth has a radius of 6400 kilometers? How do we know at what layer what do we have? So one is you observe some volcanic rocks, you observe some rocks when you're mining into the Earth, you observe these and you can know something about upper parts, but the details that you seek, details of composition, the thickness, the phase, they are more reliable if you do it indirectly. Indirectly by studying, I said, earthquake waves. You have studies of density variations. You have studies of gravity variations. We study called as gravity anomalies bolte hain. Simple logic. Okay. What's gravity? Basically attraction because of mass. So if I have a surface here and I have techniques of measuring gravity field, say yahan par gravity is x and somewhere here gravity is y. Although on average we say Earth is 9.8 meter per second square is the acceleration due to gravity, right? But ये भी fact है, it's not same everywhere. X, because the mass here is different from the mass here. If the mass was exactly the same, the gravity would have been the same. So ऐसे कुछ studies है. By knowing gravity variations, I can find out what is the correlated mass of that particular area. Okay, we call those as gravity variation studies. Okay, but this is what we'll focus on. What are the earthquake evidences? Yes, Dhruv. Mantle plumes cause hotspots, not the same things. The hotspots are the consequence of the mantle plumes. Yes. Okay, back here. So, studying earthquakes, we said earthquakes, they release energy. This energy can be electromagnetic, which I ignore. Energy is mechanical waves. The property of these waves depends on the medium through which they propagate. This is the important principle. Okay. When the energy is moving, the speed of the waves, the path of the waves, whether the waves are bending, going straight, how they modify. So that depends on medium kya hai. It depends on what are they moving through. And somehow we have correlated. Property P1 means medium M1. Property P2 means medium M2. Property P3 means medium M3. Therefore, if I know the properties, I can tell what the medium is. ये पूरा correlated है. Okay. So, this principle is used to study the interiors of the earth. And earthquake waves, they can be surface waves, they can be body waves. To know the interiors, I study the body waves. Because as the energy passes through the body, then I know at what depth, what do we have. Body waves, two types. There are P waves, there are S waves. Again, one of you called back yesterday evening, mein, sir, we have been told P waves are transverse waves and S waves are longitudinal. देखो, जो बोला, I can't justify. In most cases I've seen, you're taught right, but you understand wrong, and that stays with you. And then you conveniently put the blame कि हमें पढ़ाई गलत था. Okay? So, ठीक है, जो हुआ सब माफ कर दो, ठीक है? Go with the class here. And, you have to do some relearning here. P waves are primary waves. P waves are longitudinal waves. In P waves, the particles are vibrating along the axis. If this is the axis of energy movement, अगर energy ऐसे जा रहा है, the particles are vibrating along the axis. ठीक है? So longitudinal, along. And if this is the direction of the energy, ये अगर axis है energy का, and the particles vibrate like this. This is at 90 degrees. Or they can also vibrate, okay, even like this. So they vibrate like this. ये भी 90 degrees है. Can you all imagine here? Energy moving like this. The particles up and down. ये भी 90 degrees होगा. And the particles front and backward. ये भी 90 degrees होगा, right? Both are examples of transverse waves. If they vibrate along the line, this is longitudinal sound waves. If they vibrate like this, or they vibrate front and back, to and fro, both are examples of transverse waves. जो surface L waves हैं, वो ये वाले हैं. The particles vibrate, but they vibrate parallel to the ground like this. That's why they become dangerous. When you design buildings, some of you would know this. The building is designed mainly for carrying vertical load. The beams and columns, they have vertical load bearing capacity. The building is rising and falling, the impact will not be much. But if building is doing this, the corners will break very fast. So this is called a sway in technical engineering terms. To design a building against sway, they put more steel in the corners. If they make the corners strong, the shape remains. So L waves are more dangerous because they are transverse waves and the particles are vibrating parallel to the ground. That's what makes them a bit more dangerous. So I think I had shown the diagram to all of you also. I didn't differentiate it here. And this one was there and एक और था. You can see this one maybe. No, इसमें भी नहीं है. इसमें भी दिखा रहा है up and down दिखा रहा है ये वाला भी. The other one also has up and down. So I didn't. ठीक है, कोई बात नहीं. Now that you know it. So either ways, these two are transverse waves. And transverse waves का best example है a guitar string. You hold the wire tight, you tighten the guitar strings, and you plug the guitar. Okay, the wire vibrates, and it looks like the energy will move, okay, in one direction. Or if you have seen that gym mein hota hai, the gymming ropes that we have, okay, you hold the rope and you give it a jerk, you can see a wave moving like that. Those are examples of transverse waves. And these waves are good only when the rope is held tight. अगर rope को आपने ढीला छोड़ दिया, you will not have any waves, right? Tight का मतलब है it is a rigid body. Loose का मतलब है the shape is now variable. The more tight you hold, the better is the transmission of the transverse waves. Okay, so I hope you understand P and S waves now. Property क्या है? P waves. P waves are faster. P waves can pass through solids, liquids, and gases. P waves ka velocity, okay, increases with increasing density of the medium, and it increases with increasing rigidity of the medium. S waves. S waves are slower. S waves can pass only through solids. We need rigid bodies. S waves also, okay, the velocity will increase with increasing density and increase with increasing rigidity. Okay, these are summary of. इसमें दो क्वेश्चन पूछा है प्रीलिम्स में, लास्ट 2-3 years में पूछ दिया है. Okay, P and S waves, okay, questions in prelims, GS. Or fine here, ठीक है all of you. What are P waves? What are S waves? अच्छा, now, if you look at Earth interiors, we have upper crust. I'm looking at continents. Oceans ignore कर रहे हैं अभी हम. Upper crust, continents. We have the lower crust, continents. We have the moho discontinuity. Then we have the upper mantle, okay, which is part of lithosphere. Then we have upper mantle, which is asthenosphere. Then we have the middle mantle, we have the inner mantle. Then we will have, okay, the Gutenberg discontinuity, the outer core, the inner core. ये layers है, ये layers है more or less. Repeated discontinuity is a debate actually. In some books they'll write this, that the debates about whether that exists or not. Some say hota nahi hai because the change is so smooth, you can't differentiate where does the middle end and where does the inner mantle start. इसलिए मैं छोड़ दिया उसको. But broadly, these are the layers. Okay. Now you know the property. Upper crust कैसा है बताओ? All of you, please participate here. Upper crust कैसा है? It is hard. It is less dense, right? We have used a term called as felsic. Lower crust कैसा है? This also is hard, but here the density is increasing. Remember, we have something called as Conrad discontinuity here at around 30 kilometers के depth पे. ठीक है? I'm revising these layers with you. Hard layer, this is less dense. Upper felsic layers, lower layers, more dense. The whole thing is felsic, but इसके comparison में this is less felsic. This is more like mafic. टमाटर याद आ रहा है mafic? इससे comparison में. Remember, this is not actually mafic. Actually, it's felsic, but it is less proportionate felsic compared to the upper layers of the continents. Moho, sudden transition होगा. Moho, mantle is This one is again hard and very high density. Density continents में 2.5 है. You enter करते ही you are hitting about 4 density here. Asthenosphere. Okay. Here this becomes relatively soft. I've said it is semi-molten, right? Soft means what? It is having less rigidity. It has less rigidity. But it also has increasing density. Make sense? Okay. Okay. Then we have the middle mantle, inner mantle. These are very dense. इसकी comparison में definitely these are harder. Okay. Density can touch, I said, 7, 9 types density जा रहा है. Gutenberg suddenly changes. Outer core is dense, but it is fluid. Density of this is approximately 11. Okay. And inner core is dense, almost 13, 13.5, and it is solid. ये हमें पता है अब, right? There was a time we didn't know this. So I would study the earthquakes, waves, and how they are varying. Once I know this property, अब आप बताओ, how will the earthquake waves, okay, how will they vary? How will they change? We always talk in terms of PS waves together. ये PS set of waves है. हालांकि P waves moves faster, S goes slowly. We call them as PS set waves. Okay. Initial, hard rock, less dense. The PS waves, these are in general slow. They are slow. The velocity, P waves, most books में, they talk about the velocity of the P waves. They also mention S waves. But आप P याद रखो, that's good enough. So P waves, density is slow. The P wave is around 3 km per second. It can increase to 5 km per second. As you go inside, it becomes faster. And this property is linked to granite layer. So ये जो PS waves हैं, we call them as PG-SG waves, as in G for granite. We call them as PG-SG waves. Yeah, you can do that. Okay, I mean, if you know this table, answer is done. Then don't remember by heart anything else. And there is nothing rocket science here. You just have to remember this property. ठीक है, लिख लो, all of you can write on this point. ये दो column लिख लो आप लोग. Upper crust लिखो, all of you. Upper crust, okay, above 30 kilometers, continents. The lower crust of the continents, Moho discontinuity. Use a pencil or a pen, okay, to differentiate a discontinuity. Moho discontinuity here. Then we have, okay, the upper mantle, जो part of lithosphere है. By the way, इसका depth कितना है? यहाँ तक कितना depth होगा? 100 kilometers. This is about till 100 kilometers thickness from the surface. Write this down like a table. It will help you revise better. Okay. 100 kilometers from the surface, lithosphere. So this part is the lithosphere layer. The lithosphere layer. Then we have upper mantle, lower upper mantle, asthenosphere. ये कहां तक होगा ये वाला? 300, 350, 400 kilometers from the surface. Lithosphere. Inner mantle, middle mantle. Okay, there is one distinction here. 700-900 kilometer पे distinction होगा. Some variations here. Gutenberg discontinuity. At what depth? 2900 kilometers from the surface. The outer core, the inner core. Okay, this is, they are dense. Density varies from 7 to 9. Relatively harder than astronosphere. Okay, and then we have outer core, fluid, high density 11 but fluid. Inner core is solid, density almost touching 13, 13.5. And this differentiation is 4800 kilometers. So when I am mapping the PS waves ka property on this side, I'll map with this. I start with, okay, so I'm assuming कि कोई earthquake है, okay, earthquake is at the surface of the earth and the waves are going down. Imagine, this is the earth here, ये core है आपका, earthquake focus यहाँ पर है. This is the earthquake focus. From here, the energy is now going down, Okay, while going down, how does the wave change? And this question, how do they know the velocity for that depth? That I'll skip. वो क्या technique है? How they work out seismographs, at what depth they calculate? That I'm missing. Mantle is solid, in some parts fluid. Yeah, the fluid part is the molten part. वो छोड़ दो अभी. In this, I'm not discussing the convection cells right now. I'm ignoring the convection cells for now. Okay. So PS waves, the first layer, okay, in the upper part of the continents, above the Conrad discontinuity, the PS waves are slow waves. The PS waves, okay, correspond to granitic layers. We call them as PG, SG waves. Velocity 3 kilometers, say 5 kilometers per second. 5 kilometers per second. Okay. You go down, okay. This is denser, this is also harder. So here, the PS waves increase in velocity. They become faster. Okay. Touching 6 हो जाएगा यहाँ पर. Touching 6. ठीक है. As they cross the Moho, the speed increases even more. In the Moho, the PS waves become more fast. Okay, they touch 7. P waves ka velocity hai 7 kilometers per second. And when they are crossing this, okay, say from the crust to the mantle, बहुत fast हुआ. Okay, मोहो में बहुत fast हो गया. When crossing over at this boundary, the speed can reach P waves ka around 7.8 kilometers per second at the boundary of the lithosphere and the astronosphere. देखा आपने? PS waves are slow. The P waves 3 km per second, ranging up to 5 km per second. They're called as PG-SG waves. You go down, the PS waves have increasing velocity. The P waves can touch 6 km per second. इस सब velocity का wave, मैं P का बात कर रहा हूं. The P wave can become 6 km per second. Go down, crossing Moho. This is dense and also hard. The speed becomes even more. The PS becomes even more faster. The P waves can now touch 7 km per second, and just at the margin of the lithosphere and the astronosphere, the P waves can become 7.8 km per second. All good? Okay. Now, when they cross this, यहाँ पे क्या हो रहा है? ज़्यादा density तो है, but it is now becoming relatively softer. It is becoming less rigid. So there will be a sudden drop in the P velocity. It can fall to about 7.3 km per second. 7.8 से ये घट गया 7.8 km per second. Is it okay, all of you? This reduction क्यों हुआ है? Okay, because it has now become less rigid. Okay. Even though density is higher, यहाँ पर the control is not density. The control is now rigidity. It's like, I've got two wires. So one is a iron, okay, wire, and one probably is a rope made up of maybe coir. Okay, two tightly held. Hold it very tight. If I pluck, I'll find the waves in the iron going faster. Okay, but when I loosen the iron, even if the iron has high density, और उसको मैंने ढीला छोड़ दिया, the waves will disappear. Whereas the coir rope, because I'm holding it tight, I still have waves in it. So when the transition happens, the change is not because of density. The change is because of rigidity. The asthenosphere is semi-molten. It is softer. Okay. So it falls to around 7.3 kilometers per second. यहाँ तक ठीक है all of you here? लिखा आपने all of you? Okay. Then, when you are hitting the inner core and middle core here, again, the PS velocities increase. Again, the PS velocity increase. No values mentioned. It can touch 9 kilometers per second. In some cases, they have said even 11 kilometers per second. So, sudden drop, then it increases consistently. Both P and S waves. The P waves can touch 9 kilometers per second and sometimes as high as also 11 kilometers per second. Okay? So, this is how the PS waves are changing through the layers. Once you hit Gutenberg, Gutenberg is what? It's a fluid medium. यहाँ पर क्या होगा? Beyond this, there are no S waves. We'll have P waves, but P waves have now become again slow. They fall suddenly. The moment you cross Gutenberg discontinuity, the S waves disappear because S cannot travel through fluid mediums. S can't move through molten mediums. Whereas P can pass, but P becomes slower. Values यहाँ पर छोड़ दो. Books don't mention it, so ignore it. But in the inner core, the P waves again increase in velocity. The P waves again increase the velocity. So जब यहाँ बाहर आएगा, you have only P waves, you will not have S waves. S waves stop at Gutenberg. So यहाँ से यहाँ तक, the P and S waves. Beyond this, we have got only P waves. Is this table fine, all of you? लिखा सबने? See, in your answer writing, ये एक challenge होता है. Okay. लिखना भी सब है और word limit भी cross नहीं करना है. More importantly, time नहीं cross करना है. These are tools. So, in the answer, sometimes lot of content can be put in a table form, in a diagram form. You can just mention, okay, the P and S waves variation through Earth's interiors is as shown below. Draw the table. Table का advantage क्या है पता है? No grammar required. At, the, and, therefore not required. See that? P increases, P slows down. Okay, P disappears, S disappears. P picks up speed, that's all. If a sentence hoga, then you must mention the entire content. What you can do is, put the whole thing in the table and discuss some key important ones. Like number one, I can discuss how initially P and S are slow, they pick up speed, okay, up till Moho, and then they become slow. Or say, up till lithocerand, and then they become slow. That's one sentence. In the asthenosphere, they're slow because it is semi-molten and soft. In the inner middle mantle, they keep on increasing speed because high density and also high rigidity. And the fourth point, beyond Gutenberg, Okay, 2900 as disappears and P continues. बस आपको लिखना है 4 sentence. Details are in the table shown below or alongside. Per second, beta. All speed are kilometer per second, not per hour. Hour लिखा क्या मैंने? नहीं, second. S second, 3 second, 10.8 per second. All the speeds are in per second. Yes. Any doubts in this, anybody? All good? Okay. So back to your notes and write down 3 points here. Likho. The pattern of P and S waves. The pattern of P and S waves is as in the table above. Is as in the table above. The following are key observations. The following are the key observations. Number one, the PS waves in the granitic continental crust, the PS waves in the granitic continental crust is slower because granite has less density. Within bracket, P wave velocity around 3 km per second to about 5-6 km per second. P is from 3 km per second to about 5 or 6 kilometers per second. जो आपने यहां लिखा था वहां पे I have given you elaboration. Number 2, while crossing Moho discontinuity, the PS waves become very fast. And at the margins of lithosphere, asthenosphere, margins of lithosphere, asthenosphere boundary, the PS waves are the fastest. The PS waves are the fastest with P waves at around 7.8 kilometers per second. With the P waves at around 7.8 kilometers per second. Next, in the asthenosphere, the PS waves suddenly drop in velocity because of low rigidity. So when the PS waves, they cross cross करके जब asthenosphere में आ गए, at the margins of lithosphere यहाँ पर it is 7.8. They cross into asthenosphere. In this layer, asthenosphere में, they are in the range of 7.3 km per second. So it was increasing, sudden drop because of low rigidity. All done, all of you? Next, to the rest of the mantle, the P and the S waves consistently become fast. The P and the S waves consistently become fast. Until the Gutenberg discontinuity. Gutenberg discontinuity at 2900 kilometers. Gutenberg discontinuity at 2900 kilometers. Gutenberg यहाँ पर है. Okay. The mantle ends and now you have the outer core. So it keeps on increasing. बढ़ते चला जा रहा है. Cross into this one. Okay. Now things change. Write down. Because the outer core is fluid. Because outer core is fluid. The S waves disappear. S waves disappear. But P waves continue with lesser velocity. The P waves continue with lesser velocity. Okay. यहाँ तक P और S waves दोनों हैं. You come here, S is gone. S can't move through this. P continues, but P have become slightly slower. And next, through the inner core, the P waves again pick up speed. The P waves again pick up speed. I think nothing to memorize here as such, bearing the velocity. So I encourage this. देखो, ये जो details है ना, 7.3, 7.8, 6.5, the depth of 2900 kilometers. These details convinces the examiner कि हाँ आप पढ़ के आए हो. Otherwise, write general लिख दोगे आप. Upper part slow, it increases, becomes slow, again increases. Okay, this is a very casual answer then. How do you bring credibility in an answer? हाँ पढ़ लेके हाँ आपको ये चीज पता है. When I exactly mention some minute details, so I encourage this. Do not miss out the details, right? So with the data and facts, okay, your answer becomes more like a studied answer. All done, all of you? Any doubts in this? Any doubts in this? Anybody? Yes. In the no, actually यहां पर स्लो हो गया. यहां पर उतना टाइम नहीं है बढ़ने के लिए. इसी इनर मेंटल. ओके, inner mantle, outer core and inner core. It's like a car accelerating, a powerful car. Okay, यहां से यहां तक a lot of time for the speed to increase very high. but यहां पर आपने ब्रेक लगा दिया. If this thickness was much, अगर उतना रनवे होता, then the speed would have kept on increasing. but इसका thickness उतना नहीं है, okay, for the speed to make up. So the highest speeds actually measured are in the inner mantle, not in the inner core. It's like I'm going very, very fast. Okay, I put a brake and I again accelerate. But करते करते रोड खत्म हो गया. So I could not hit my previous high speed. If the road was long enough, then maybe I would have gone even faster. So graph देखोगे, the highest speeds you have recorded are in actually the parts of the inner mantle. ठीक है. In fact, एक diagram है. I'll show that to you. Maybe that will help you clarify some things. आपके book में है. Page number 111 or 110. हम चाहेंगे आप ये ग्राफ बनाओ. Okay, back in your notebook also. See here. Okay, so surface of Earth. On this side, we are plotting the depth of the Earth. Okay, in 1000 meters, so as in kilometers. And this graph is for S wave. This is for the P waves. Okay, S waves. Initially तो कम है. It increases. Okay, when crossing 100. Okay, यहाँ पर you can see there is a slight almost tapering off here. Then again increasing. Okay, inner mantle में बढ़ता चला जा रहा है. And then it hits your Gutenberg 2900 kilometer, right? Suddenly fall off velocity. On this side you have got velocity. P waves देखो. P waves are ऐसा in general slow. Look at the P waves, you can see the difference better. The slow waves, increasing speed when crossing here, kind of tapering off, again increasing, okay, and then sudden fall of speed. Zero नहीं हो रहा है. Zero means it must hit here. Sudden fall and then increasing, okay. But by time hitting the inner core, इतना कम है, यहां से ज्यादा बढ़ नहीं पाया. If you look at the maximum speed, कहां बना आपका? At the inner mantle. It's almost touching here. Okay, यहां पर तो वैल्यू 12, 13 टाइप्स यहां पर हो रहा होगा शायद. The highest speed of P waves are in the inner mantle, deeper part just before the Gutenberg. उसके बाद में it falls so much to again pick up and increase much. उतना टाइम है नहीं इसके पास. But there's no S waves here. Is it okay all of you here? So I'm leaving this diagram on the screen for some time. आप please इसको copy कर लो. If you have it in your textbook, please copy this graph. You can ignore this one. बना लो. It's not a big deal in any case. Yeah, it's on the screen. Please make this graph. Values लिख लो ना. Just mention increasing speed और क्या? Kilometer per second. Yes. On the what? वो इससे क्यों कंफ्यूज कर रहे हो? हाँ, वेरी कर रहा है, बट कुछ एवरेज वैल्यूज है, उठाया हमने. बट आप जो कह रहे हो कुछ और चीज कह रहे हो. P waves. What is NS? I do not know. P is primary and S is secondary. Why primary? Because they are the dominant waves. They are the faster waves. Secondary because they come afterwards. So बाद में if I'm recording at a place, the P waves will hit me first. Generally, the S waves come 8 seconds later. Generally, there's some time lag in P and S waves. So what hits you first is primary wave. तो second बाद में आएगा, उसको बोलते हैं S waves और secondary waves. दोनों साथ चल रहे हैं, राइट? इन दोनों कंपैरिजन नहीं है. ये कंपेयर करो. यस, दे ऑलमोस्ट आर फास्टेस्ट इन योर मेंटल. No, Anugya, I do not know about that part. I've not heard gamma rays as called as primary or secondary. I have a sense of the diagram. You don't have to know every small bend and curve. A small sense at what depth they are increasing, tapering off, sudden fall. You have to draw mainly this. Okay. This increase, taper and drop. अब ये दिखाना है. Okay. This is less because this part is the continents and the lithosphere. We've entered, okay, the mantle here and then fall. आपको ये वाला part दिखाना है. Okay. And this part is your asthenosphere. So look at how fast the increase happens here. और यहाँ पर it's not increasing too much. So somewhere here is your asthenosphere types. 300 तक kilometer तक approximately. Yeah, it says here. Upper mantle. Maybe here like this. Can I move on from here now? Page 110 or 111. Whatever edition you have. Samindra Singh, Geomorphology. Okay, I am moving on. ये आप कर लेना अपने आप room में, back in your room. Let's move on now. अच्छा, now. One more discussion. Now see how the path of P and S waves change through the interiors of Earth. How the path changes. How the path of P and S waves change as they move through the interiors. The previous discussion was how does the velocity change? उस heading दे दो आप. The previous section, how does the velocity change as the P and S waves move through interiors? This is now about how the path changes as the P and S waves move through those interiors. Okay, so the rule is when density of the medium change, P and S waves will refract, as in they will bend. When density of the medium changes, the P and S waves will refract, they'll bend. Refraction. With increasing density, P and S waves will bend outwards. With increasing density, the P and S waves will bend outwards. देखो आप, when there is change in, write down, when density of the medium changes, the P and S waves will refract, as in the P and S waves will bend. Bending का क्या direction होगा? With increasing density. अगर density बढ़ रहा है, the P and S waves will bend outwards. Okay, so if this is layer 1, this is layer 2, and layer 2 का जो density है, it's more than layer 1 density, then when the P waves are moving, they will bend outwards. This is the perpendicular normal. अगर ये L3 है, is more dense, then this will bend even more outwards. ठीक है? The bending is outwards, not inwards. And otherwise, when density falls, the P and S waves will bend inwards. Density falls or rigidity reduces in either case. When density falls or the rigidity reduces, the P and the S waves will bend inwards. No, don't do that, Abhirup. Those laws of refraction for light are different from the laws of refraction for P and S waves. Light का थोड़ा अलग behavior है. Don't write it down, just for the sake of your clarification. Light का जो property है ना, light in tensor medium becomes slow. Therefore, light in tensor medium will bend inwards. P and S waves in denser medium, they become fast. ये उल्टा होता है. Light wave जो है slow हो जाता है. So light wave will bend inwards. P and S waves, they become fast. Therefore, P and S waves in denser medium will bend outwards. ठीक है? The Abhirup, don't go that route, please. ये magnetic वगैरह घुसाओ मत, फंस जाओगे. Okay, your concepts tell me you need lot of revisions. Okay, so you asked me, so I'm answering here. Just इतना रखो, that's all. Please, some of you have physics background, hold that back. इतना ही लिख के आ जाना है. ये भी extra पूछा तो बताया मैंने. So what happens for light is different from what happens for P and S waves. For light, this is air, this is water. For light, okay, light waves in water will bend inwards. Water का density is more than air density. ये अंदर आ जाएगा. In case of PS waves, okay, it'll come, it'll not inward, it'll go outwards. This should have gone straight, ये अंदर आ गया. This should have gone straight, ये बाहर चला गया. ठीक है? No, the bending is not for electromagnetic waves. We're talking about okay, light as particles, उसमें आता है. ठीक है? All done here? आपको बस यही जानना है. If the wave's velocity increases, it will bend outwards. If the velocity reduces, it will bend inwards. So, if this is the Earth, these are the concentric zones of the interiors. Energy starts here. It should have gone straight, but it keeps on bending outwards because it is becoming more and more dense. It should have gone straight. It keeps on bending outwards. Both P and S waves. Outwards. Outwards. This is also outwards. Outwards. ये core है. At the core, now the S waves can't pass. Okay. So we have S waves का ये diagram. We don't have any S waves in this part here. Okay. So the bending outwards है, it's because the density is increasing as I go inside the Earth's interiors. So take your page now, write down path for S waves. I'm sure all of you have seen this in CRTs. I'm repeating it, that's all. This is the core, path for S waves, bend outwards, outwards, become tangent here, outwards, outwards, becomes tangent here. And this angle at which they come out, okay, is about 105, 103 degrees. और range vary करता है. Or fine, all of you? The waves are bending outwards. Okay. Core, because outer core is fluid. Okay. So यहाँ पर आकर the S waves can't enter. They come and hit here, they can't enter. So they can't enter. That's why this entire part has no S waves. We call this part as what? S shadow zone. Called as S shadow zone. 105, 103. Anybody knows the angle क्या है? अगर ये center of the earth है ये वाला, okay, this point, if you join a straight line, this and with this angle is 103. This is what it means. Okay, measuring this angle, this line from here to our center, okay, and this vertical axis ऐसे. This angle is 103. Means book side down यही लिख देते हैं 103, 105 degrees. S wave diagram. All done? दोनों तरफ लिखो 105, 103, 105, 103. You don't have S waves here. Called as S shadow zone. So add one sentence here. The S shadow zone is because S waves cannot pass through the fluid outer core. The S waves cannot pass through the fluid outer core. बस ये दो पॉइंट जानना था आपको. The waves will bend outwards because increasing density, and they can't cross the core because it is fluid. अरे अगर इनर आउटर कोर पार ही नहीं कर पा रहा है तो इनर में पहुंचेगा कैसे? राइट? अगर प्रीलिम्स रुक गया, मेंस तक जाओगे कैसे? So beyond prelims, the journey ends. Unless you have a method to jump this. Okay? Because the S can't cross the fluid outer core, we don't have S waves beyond 103, 105 degrees. The next one, path of the P waves. The P waves का diagram क्या है? Like S, bend out, bend out, bend out, tangential here, bend out, and tangential at it. So ये वाला angle is also 105, 103. Because P and S waves यहाँ पर साथ चलते हैं, both are together. This also is 103, 105 degrees. But now what happens is P waves hits the core. It won't bend outwards. It bends inwards. अंदर गया. Then inner core. It again comes out. Again bends. And then it comes out here. There's lot of refraction changes here. The P waves comes out, but lot of change होता है. It comes, hits here, it goes inwards, outwards, again this, then it comes out here. If this core was not there, a core नहीं होता, then okay, the P waves would have continued smooth, continued smooth, continued smooth, continued smooth. Okay, but because there is a core, the core will deflect the waves. Okay, the waves can't pass smoothly. They bend in, they become slow. Again come out, so there's changes here. So the details I'm skipping here. Okay, just know that they don't come out smoothly here. They come out a bit more farther away. This angle approximately 145. Some books write 147. Some books can write 150. उस range में रहता है. Here and here also same thing. 140, 145, 147 is range. For the S waves, the whole thing is S shadow. For P waves, okay, दिस इज द P shadow. यहां पर P waves नहीं है. This is the P shadow. Here we have P waves, here also we have P waves. So this part has no P waves and this part has no P waves. So if I ask you, why do we have S shadow? Because S waves can't cross beyond the outer core. Why do we have P shadow? Because P waves are further bent inwards and the path is deferred because of change of medium. Okay, but P waves can pass. ये gap क्यों हुआ? Because ये अंदर आ गया. That's why. Not that they can't pass. So write one sentence here. The P shadow zone is because the fluid outer core deflects the waves inwards. The fluid outer core deflects the waves inwards. Shweta, those details I will not know exactly at what depth they do what. Okay. In general, they become slow, they become speed, they again become slow, and then they come out. इतने में छोड़ दो. That's it. The ekdam details we don't require. The typical diagram that you all are familiar with are these two diagrams. Okay. So S waves यहाँ पर 103 लिखा है और 105 range, and the P waves as it varies 145, some book at 147, 150, P shadow, and the entire thing is S shadow. Is it okay, all of you here? This is the question they've asked twice in geography optional, and I think once or twice in GS पूछा हुआ है. Okay, no other questions. Another diagram that says it is 145. Okay, in this we have got 150. So I want you to know the range is there. Don't be bothered about the exact number. All fine? So आपका जो last इस section का the last 4-5 pages है, that's the key part of your answer if they ask you. And table आप याद कर लो. It's a good, nice way of summarizing what happens as the P and S waves are transmitting. In fact, I did bring your NCERT book also. Okay, so if you are keen, and I'll suggest read this. Okay, along with your class notes. So this is in chapter number 3 में है. Okay, is a very clear diagram shown. This NCERT pages का ही है, which I have used on the screen. Okay, so chapter 3, it's a reading of not more than 1 or 2 hours. Try finishing that part, please. The fundamentals of physical geography, class 11. Okay, I'll move on from here now. एक बार revise करो and ask me if you have any doubt, all of you. Online, offline, both. Revise once, and any doubts you have, the table is the main one, and the graph that I had made you draw. And don't look at all the minor details of the graph. Exact bends नहीं चाहिए हमें. Broadly, how they have changed is what we need. Ask me if you have any queries to clarify. Dhruv, okay, ठीक है, I get your question. He's asking me, अगर ये earth core and the waves here, ये shadow zone है, S shadow. So will we not have the earthquakes in this zone? क्या आंसर होगा? ये shadow zone किसका है? When the earthquake is here, can the earthquake be here? उसका फिर ये shadow होगा. Okay, so I will not have earthquakes in the shadow zone if this is the earthquake source. So it doesn't mean that the shadow zone is same for all earthquakes. Earthquake जब यहां होगा, the whole thing shifts. Earthquake यहां होगा, whole thing will shift. So don't generalize and say this S and P shadow will not have earthquakes. They will not have earthquakes for that particular location of the earthquake source. Okay, so this source की वजह से I will not have any recordings here. Yes, the next one is I can still have surface waves. The body waves है, right? The surface waves can propagate. ठीक है? Okay. Yeah. Back to your notes. Yeah, Dhruv, I hope I answered your question. Anybody else? Yes, Anugya, 2 क्या, 3 क्या, जो देखना है देखो आप. You get the concept? We can move on then. Any other doubt? Anybody? We move on then. Krish, okay. Take a fresh page and give a heading. Give a heading. Continental drift theory. Continental drift theory. GS में इससे भी 2-3 क्वेश्चंस हैं एंड प्रीलिम्स में भी, मेंस में भी. In optional, they have been asking more tricky questions. So these are very elementary questions. Okay, but don't ignore it. The continental drift theory. Okay. So now some of the mysteries of geophysics include number 1, how was Earth formed? How was the Earth formed? Number 2, how did crustal differentiation happen? How was the Earth formed? Number 2 is, how did the crustal differentiation, का मतलब क्या है? How the continents and oceans became different. Oceans are now granite, oceans are diorite. Sorry, continents are granite, continents are diorite, oceans are basalt. ये अलग-अलग कैसे हुआ? We call this as crustal differentiation. How was the Earth formed? How did crustal differentiation happen? Within bracket लिखो आप. Oceans and continents separating out. Next, how do the oceans and the continents change? How do the oceans and the continents change? The next, how do volcanoes and earthquakes happen? How do volcanoes and earthquakes happen? And how are mountains formed? How are mountains formed? And mountains में a bigger challenge is to explain what's called as fold mountains, right? Fold mountains बड़ा interesting है. Fold mountains, they are among the highest mountains. Fold mountains have marine sedimentary rocks. Fold mountains are long chains. Fold mountains are parallel ranges. The fold mountains are lot of mysteries answered recently. Himalayas are fold mountains, Alps are fold mountains, Rockies are fold mountains. So they are not any mountain, they are a long chain of mountains. The ranges are parallel ranges, plus there are sediments which have marine type of origin. It's like the mountains were once inside the sea and now they have got uplifted. Okay, that is the mystery of the fold mountains. So we want some theory to explain all of this. Okay, and one more question add karo. Do continents move? Do continents move? एक older concept था called as the concept of permanency of oceans and continents. This is an old concept. Write down. An older concept called the theory of permanency of oceans and continents. An older concept called theory of permanency of oceans and continents had declared the oceans and continents once formed do not change, and they are formed all at the same time when Earth was forming. And they are formed all at the same time when the Earth was forming. The Earth बन रहा था, उसी टाइम में ओशन बन गया, कॉन्टिनेंट्स बन गया. That's it, stop. उसके बाद में no changes, no movement, no modifications. Which means if I go by this theory, all continents have the same age. All the oceans have the same age. The ocean continents don't move. The ocean continents are permanent. They don't shrink. They don't increase. They don't get destroyed. Okay. This was the old idea. Okay. Let's write down. Give heading. Drift theory. Drift theory. Write down. First point, likho. The idea that continents can move and oceans are dynamic. The idea that oceans can move and the continents can move. The idea that continents can move and oceans are dynamic was increasingly getting accepted. But it was Taylor. Frank Taylor. It was Taylor in 1908 who gave the first model of continental drift. बहुत लोग जान रहे थे कि हाँ सर चेंज होता है, but nobody had given a proper theory. Okay, there are some speculations, some ideas are there. Taylor is the first man to say, there's a process to this. Okay, so for Taylor, according to Taylor, there was a large continent called Pangaea. The Pangaea broke into northern Laurasia and southern Gondwana land. there was a large continent called as Pangaea. The Pangaea broke into northern Laurasia, Laurasia, northern Laurasia and southern Gondwana land. The two blocks again collided and formed Eurasian fold mountains. The two blocks again collided and they formed the Eurasian fold mountains. So it's like there's Earth, there was a large continent called as Pangaea. The Pangaea broke into two parts, a northern part, southern part. Northern is called as Laurasia, southern called as Gondwana land, और बीच में एक sea है called as the Tethys Sea, and again collided. The northern one collides with southern one, and we have a mountain system here. Okay, this was very superficially. Taylor ये बता चुके थे already. There's Pangaea, there's Laurasia, Gondwana land. They again collided with one another. टूटने के बाद में forming the fold mountains, Alps, Pyrenees, the Hindu Kush mountains, Himalayas, like one continuous east-west mountain range. Okay, and according to Taylor, it was the gravity pull of sun and earth, sun and moon. It was the gravity pull of sun and the moon. Call this as the tidal pull, responsible for continents breaking and moving. For Taylor, the gravitational pull of sun and moon, also called as the tidal pull, the tidal force responsible for the continents breakup and continents moving. Is it okay? The brief में 4-5 points में. The idea continents can break and move was given by Taylor. This was among the first concepts which challenged the idea of permanency of oceans and continents. ये idea बोला है कि नहीं, oceans are not there always. They form, they get destroyed, continents बनते हैं, टूटते हैं, move होता है. Okay, there was a large one called as Pangaea. The Pangaea broke into Laurasia and Gondwana land. They again collide to form the fold mountains. And all of this because the sun and moon are exerting some force that are forcing the continent blocks to move. Is it okay, all of you here? Okay. Next, write down continental drift theory of Alfred Wegener. Taylor का आया 1908, Wegener's got published in 1912. German में, and then a few years later, it was translated into English. The continental drift theory of Alfred Wegener. तो इसको थोड़ा डिटेल बता देंगे. And remember one thing, that Wegener was taking a lot of ideas from Taylor plus some other ideas that he had. Okay. So within bracket mention, many concepts of Wegener are borrowed from Taylor. Many concepts of Wegener are borrowed from Taylor. So what are the postulates? इस theory के main components, ideas क्या हैं? What are the postulates of? Okay, number one, Earth's structure is Sial continents floating over सीमा oceans. ये पहला आइडिया था कि अर्थ का जो स्ट्रक्चर है, अरेंजमेंट क्या है. He said the continents are Sial, the Sial continents which are lighter and which are harder. They are floating over the oceans which are Seema. So this is the Seema layer. This is the Seema layer. And on this we have the Sial block. On this we have the Sial block. The Sial continents are floating over the Seema oceans. So now you know ye galat idea, right? This is wrong. Now we know that the lithosphere floats over the asthenosphere. और lithosphere में दोनों है, oceans भी है और continents भी है. Okay? One idea. Second, there was a supercontinent. There was supercontinent called Pangaea. Since 350 million years ago. एक था Pangaea था. There was a supercontinent called Pangaea. Okay. Since around 350 million years ago. In geological time scale, we call this as Carboniferous times. Okay. There was a Pangaea, a supercontinent. Wegener doesn't tell us what happened before and how Pangaea was formed. ये नहीं बताया इन्होंने कि पहले क्या हुआ बताओ. अर्थ का हिस्ट्री इज अर्थ इज ऑलमोस्ट 3.6 बिलियन years old. आप बता रहे हो 300 million years. कि पहले क्या है बताओ. Wegener had no answer for that. Or how was Pangaea formed? No answer for that. Around mid-Mesozoic, 200, 180 million years approximately. Around mid-Mesozoic times, the Pangaea broke. The Pangaea broke into same idea. The northern one was called as Laurasia, also called as Angara land. Southern one called as Gondwana. Around mid-Mesozoic times, the Pangaea broke up into two parts, the northern Laurasia and the southern Gondwana lands. ठीक है? The continental blocks floated north and westwards. The blocks, they floated north and they floated westwards. In contemporary plate tectonics, the continents can move in any direction. Look at the modern understanding, कुछ जरूरी नहीं है that they must move north and west. But Wegener said the continents, once they break up, they move north and they move westwards. Okay, which is the wrong idea, but he said so. The next point, as the continents float over the Seema, they scrape the Seema floor and the sediments pile up as mountains on the leading edge. As continents floats over Seema, they scrape the Seema floor. Scrape means like the shaving. They scrape the Seema floor and the sediments pile up as mountains on the leading edge of the continents. Leading edge of the continents. What I mean by this? This is Seema. This is the Sial block. Sial block moves like this on the Seema floor. There are sediments, there are rocks. While moving, these are getting scraped. They pile up here. They pile up here. They form mountains. So this is the side ahead. We call this as the leading edge. This is the side पीछे is called as the trailing edge. पीछे रह गया. The mountains are on the leading edge. On which side do we have Rockies Mountains? North America के? What side? Western side. Andes on which side? Western side. Looks fine, possible. We said the continents, they're moving north and they're moving towards west. Moving towards west. Sediments pile up here. Which side of Africa do we have Atlas Mountains? You know where Atlas Mountains are? Northwest hai. Possible? Okay, continents are moving north and westwards like this. Yahan form ho gaya. So you can use this theory to explain the mountains of North America, South America and Africa. Problem kahan hota hai? Himalayas. एक तो हिमालयस इंडिया का लिंक है, वैसे भी लॉ नहीं मानने वाले हम लोग. आपको जो बोलना है बोल लो, हमारा अपना लॉ होता है. हिमालयस तो कोस्ट पे है ही नहीं, forget about north or south, right? And the great dividing range of Australia. The mountains of North America. यहाँ पर है ऐसे Rockies Mountains. We have South America, Andes Mountains. In Africa, we have mountains here called as the sorry, yeah, Atlas, sorry, thanks. Atlas Mountains. And further, you look at Australia, the mountains are here. This is the Great Dividing Range. So, it can't explain this, but this is okay, and this is okay. Himalayas can't explain again. Yes. नहीं, मेरी सारा मिस्टेक हो जाएगा. यही 3 बता सकते हो आप. Write down. This idea may seem valid for, Rockies Mountains, Andes Mountains, and Atlas Mountains. Rockies Mountains, Andes Mountains, and Atlas Mountains. If the idea of continents moving north and westward is accepted. If the continents moving north and westward is accepted. But this theory can't explain the mountains of Eurasia. The mountains of Eurasia, Himalayas, Alps, and the Great Dividing Range of Australia. They can't explain the mountains of Eurasia and can't explain the Great Dividing Range of Australia. Whatever I am sketching on the board, साथ quick sketches. The sketches will get better slowly, gradually, but make it a habit. Your geography will not fetch you marks until you have got diagrams in your answers. Okay, small illustrations, whatever. This was also a small diagram that we had here. Okay, we have some sketches while discussing how they move, like Taylor's ideas. Small sketches, हाथ क्या बनाते रहो. Okay, and you don't have to use a separate color pen. उसी में use करना है करो, no worries there. But be fast in drawing the sketches. This is the postulate of Wegener. Okay? Okay. Give a subheading. Evidences in support of Wegener. Evidences in support of Wegener's continental drift theory. Support of Wegener's continental drift theory. क्या अरविंद, what 5th point बताओ? What did I miss out? क्या गलत लग रहा है बताओ, मैं कुछ मिस किया आपका? What is the 5th point? Oh, अच्छा, you wrote सीमा scrape सीमा. सियाल scrape. क्या मैं डायग्राम गलत बना दिया क्या? क्या देखा, देखो प्लीज. What do you write down? सियाल सीमा और सीमा सियाल, क्या लिखा? सियाल scraping सीमा, right? As? Yes. Yes, ठीक तो है. Okay. As continents float over सीमा, they scrape the सीमा floor. इसमें क्या प्रॉब्लम है? आपको ये नाम सीमा पसंद नहीं है, पुराना कुछ दर्द है तो अलग बात है. तो जो नाम अच्छा लगता है रख लो. Okay. All fine, all of you? Okay. Now, what are the evidences? Now, what they're doing UPSC is, before 2013-14 types, we had 60-mark questions also. 60-mark questions means almost half an hour writing each answer and writing across 4-5 pages. So they used to ask, explain the drift theory pura bata de. Now you don't have 60-mark questions. You have now 20-mark questions, 15-mark questions. So now they ask you parts of the theory. So pura nahi puchenge. They'll ask you just tell us, okay, the idea of mountain building of Wegener. Tell us the idea of Pangea and its breakup with Wegener. They can ask any one of the evidences as one short note. Okay, so be ready for those short answers. You know, there are 4 evidences of Wegener. And so when I say evidences, these evidences were given by Wegener himself. The 4 evidences in support of Wegener's theory. What are they? Number 1 is, okay, the jigsaw fit evidence. The jigsaw fit evidence. The evidence of matching a shape of the coastlines. Number 2 is structure evidence. It's about matching the rocks, the types and their age. Okay. The third, fossil evidence. And the fourth is paleoclimatic evidence. The jigsaw fit evidence or the evidence of matching shape of the coastlines. Number 2 is the structure evidence matching the rock types and the rock ke age. Fossil evidence, and the fourth is paleoclimatic evidence. Okay, they can ask you in any one of them. The first one, the jigsaw fit evidence. The jigsaw fit evidence. Write down. The east coast of South America, the east coast of South America seems to match and fit. Seems to match and fit the west coast of Africa. West coast of Africa. This was observed by many scholars. This was observed by many scholars. Like Antonio Pellegrini. Many scholars like Antonio Pellegrini, like Benjamin Franklin. Benjamin Franklin. But nobody explained the match convincingly. But nobody explained the match convincingly. See, if you look at voyages, right? Starting from 1400s okay, and 1300s rather, the Spanish and the Portuguese were making the world maps. And when they made the world maps, they already were traveling along the east coast of Africa to bring slaves. They're traveling to South America, Brazil coast. So उनको shapes के बारे में पता था. If you look at the shape of South America, okay, it's something like this. The South American coast hai, and that's Africa. Okay, and these two shapes, they can fit into one another. Okay, South America almost looks like it can go and fit into this part here like this. ऐसे fit हो जाएगा. ये observation उनके पास था, but nobody knew why this is there. So they observed, very interesting, and they would keep quiet about it. Write down. Wegener explained that the two continents were once part of Gondwana land. The two continents were once part of Gondwana lands, but broken and moved apart. But broken and moved apart. Okay. So if shape is matching, and around that this shape fit was also found for parts of North America, and Africa, and also in parts of Chinese coasts, and Madagascar coast. If you look at Madagascar, shape ऐसा ही है कुछ. This is shape of Africa like this, and Madagascar is something like this. It again fits into the coastline, right? So Wegener said ये सब एक साथ थे पहले, बाद में अलग-अलग हो गए. ठीक? Number 2 is the structure match. So some said that this shape fit is not very confirmatory. हो सकता है it was accidental, maybe it's a coincidence maybe. Okay, just because shapes are matching, you can't be sure about they were part of, because see, the fact is you have ocean currents here, you've got waves here, you've got winds here. The winds and waves can modify the coasts. So they said that this shape match is not a good one. We want something more convincing. So then they studied what type of rocks are here and what type of rocks are here. What type of rocks are here and what type of rocks are here. Because see, if the shape match is there along with rock match, फिर तो almost confirmatory है. Whatever rock we have here, exactly same type of rock is here. Then you can't dispute it. And that's what they found. So I have one diagram for that. Yeah. So see this one. So when they were mapping, they found these are the rocks of Congo Basin, rocks of Argentina, Paraguay, very, very same. Rocks of Brazil, rocks in parts of West Africa. There is a very good match in these type of rocks. These rocks here are approximately about 2000 years old, और ये rock इधर में भी exactly 2000 years old. In Brazil, in some of these parts, we have got gold deposits. और same gold deposits, Africa में यहाँ पर country called Ghana है. The same gold deposits are here. If you look at some of the rocks, यहाँ पर ये Namibia, is Namibia here. Namibia, Angola is something called as biplateau. This biplateau rocks are very similar to these areas they called as Patagonia regions. Again, very similar here. So when you are matching the rocks, they found there is no overlap, and not just here. They found this also for, look at this one here. Okay, they found same type of rocks in parts of Northwest Africa and parts of North America. You almost are together. Rocks of Iceland and rocks of Sweden, again Norway. There's some match here. Ekdam same band of rocks. So Eastern America, Eastern North America, Africa, and even parts of Spain, France, Portugal. We have almost one type of rock. So this confirms that this can't be a coincidence. There's some pattern, and like I said, rocks are mixtures. Remember mixtures? Okay, they will vary. Okay, rocks are not compounds. Mixtures hai, and mixtures, same type of rocks across thousands of ocean kilometers. This can't be a coincidence. Okay, write down. The matching shape of the coastlines were supported with matching rock types. On continents across oceans. Matching rock types on continents across oceans. 1, 2, 3, 4 points. Number one, the Brazilian highlands, which are about 2,000 years old, which are about 2,000 million years old, not 2,000 years, which are about 2,000 million years old, seem to match the highlands of West Africa. यहाँ पर West Africa में there are some mountains here called as Fouta Jalon, Fouta-Jallon, Fouta Jalon rocks matching the rocks of Brazil highlands. Okay, we have one more mountain called as Loma Mountains, Loma. The rocks of Loma Mountains of West Africa, the rocks of Fouta Jalon of West Africa has a match with the highlands of Brazil, and both have approximately 2,000 million years of age. Number two, the gold deposits along Brazil coast, are similar to the gold deposits of Ghana. The gold deposits of Brazil coast are similar to the gold deposits of Ghana. Number three, the rocks of Patagonia Plateau. Patagonia is part of Argentina. The rocks of Patagonia, Patagonia, Patagonia Plateau, are similar to some of the rocks of Angola and Congo. Next, rock match of East North America, Eastern North America with Northwest Africa and Iberia. Spain ko we also call as Iberia. This is the Iberian Peninsula. Iberia is Spain and Portugal together. same as Iberia. क्योंकि आपके geography में यही चाहिए. We need places names. Don't just write rock match and move on. अब बताना होगा which place, what location, and draw a sketch map, okay, of at least one continent, and you are done. Okay, and not many of us know this. You know, the rocks of Madagascar are similar to the rocks along the coast of Malabar in Karnataka. The highlands of Karnataka and Bangalore also, okay, they are very similar to rocks of Madagascar, which implies India was somewhere here. What we find it up here, India was somewhere here, like this. So there is some match here along the Karnataka coast, Malabar coast, and the Bangalore highlands. Right down. There is match of rocks. There is a match of rocks of Madagascar with southern Western Ghats. Match of rocks of Madagascar with southern Western Ghats in Kerala and Karnataka. In Kerala and Karnataka. ये 4-5 examples of the rocks to match. Now, यही चीज को, okay, in 1964, there was a man called Edward Bullard. Edward Bullard. What he did was, see, this is, I'm drawing the cross section, okay, this is the continent. The continent. And this is, say, the ocean water here. What Bullard did was, Bullard went down the water. He went as deep as 1,000 meters. And then he said, let me compare the rocks at 1,000 meters, okay, in South America with rocks at 1,000 meters along African coast. And there he found the match was even better. Which means, जो surface पे जो match है, वो फिर भी थोड़ा disturbed है because of erosion. The rivers have cut now, the waves have modified, like the glaciers are modified. Under the water, there can't be much rivers. There can't be any river for that matter. The match was even better, both shape and also rock type, confirming the continents were once part of one large block of continent. Write down. This was confirmed by Edward Bullard. These were confirmed by Edward Bullard when he matched the shape and the rocks. When he matched the shape and the rocks at 1,000 meters depth under the oceans. At 1,000 meter depths under. When he matched the rocks and the shape at 1,000 meters depth under the oceans. In some books they might write 1,000 meter isobath bolte hain. You know what are contour lines? What are contour lines? Lines joining places with same height above sea level. Isobath are lines joining places with same depth under the sea level. Bath means depth. Batholith. Right? Bathymetric means depth under the water. Okay? So, Edward Bullard matched the rocks and the shape of the continent edges at 1,000 meter isobath. Isobath metric studies in proof of the continental drift. Right, next. This is the same discussion. Next point. The rock match was also achieved for. The rock match was also achieved for the coal resources of North America and Europe was also achieved for coal resources of North America and Europe. Now watch here. In North America, these are the important coal fields. Appalachian Mountains coal fields. We have some coal in this island called as Newfoundland Island of Canada. We have some coal in UK called as Pennines coal. This is called as Newfoundland coal. And we have coal, this is called as Appalachian coal. We also have coal in parts of Belgium. Belgium is called as River Maas, M-E-U-S-E. Okay. River Maas coal fields. These coal fields are actually one continuous belt. Okay. In North America, we have the mountains called as Appalachians, A-P-P-A-L-A-C-H-I-A-N-S. Appalachian Mountains of North America. Appalachians, the island called as Newfoundland, the coal field called as Pennines coal field of Britain, Belgium is called as River Maas, M-E-U-S-E. River Maas or river, you write as Musi, pronounce as Maas, of Belgium. ये coal fields हैं. This is an island, this is a mountain, this is a river, and we have Appalachians. Again, it's a mountain in North America. Matching coal resources across Atlantic Ocean. I'm holding the screen. बना लो इसको. Ruhr is further. Okay. Ruhr is not this belt. और अंदर है, same time है, but not exactly one. This is one continuous belt. ये पूरा एक belt of coal fields है. No, this is under rock. Coal is a rock. Belgium, the river called as River Maas, M-E-U-S-E. The Germans crossing Ardennes forest, cross River Maas. It becomes the Franco-Belgian borders, M-E-U-S-E, River Maas. There are two lines यहाँ लिखो आप. Okay. The coal fields of eastern US, seem to extend northwards and across Atlantic. They seem to extend northwards and across Atlantic into the coal fields of Britain, Belgium, and North Sea. I don't know if you know this or not. North Sea has lot of oil also. Okay. There are coal fields and the water also. So the coal fields of Appalachians, they seem to extend northwards and across Atlantic into Belgium, Britain and parts of North Sea. Within bracket write down. This was observed by Schneider, a German scholar, Schneider, but he couldn't explain this. The similarity of coal fields of North America with parts of Europe. Also by Schneider. Okay. The drift theory can explain this. The drift theory can explain this. Because these continents were once joined together. Because these continents were once joined together. ये आपको दिखा देते हैं. Make sense here, all of you now? They all were once together here. So these coal fields, these rock types, they have got very good match. Okay? Feature observed by a German scholar called as Schneider. So your challenge यहाँ पर होगा जगह का नाम याद रखना. And along with small sketches. So these diagrams I'll share with you on your post class notes. मिलेगा आपको सारा, ठीक है? But इसको अपने notes में उतार लेना, please, all of you. Whatever I'm sketching here. Plus whatever you can add from these, and these diagrams are not in your textbooks. You go with the diagrams and giving this part of your post class note support there. ठीक है? चलो, that's for today. And in your NCERT book, this is chapter 4. And I'll suggest ये chapter 4 का जो पहला 3-4 पेज है पढ़ लेना. This is the topic of tomorrow also. This NCERT textbook. Okay, chapter 4. I have added all the points plus something more beyond NCERTs. मैंने add कर दिया है. So read the first 4 pages and come tomorrow. Pennines are in UK, Abhiroop. Pennines are in UK, Britain. Catch you tomorrow at 12 o'clock again. Fatima, what did you miss out? The rocks of Brazil Highlands are similar to rocks of West Africa. ये वाला part. This is Brazil Highlands. Okay. Similar to rocks of Western Africa. These two. The last point, that's all. Yes, Shweta, thank you so much. Thank you. Bye. Yeah, tomorrow we continue. Hmm.